2015 it was basically well above the height of the gate. It flooded all of these properties in here and then flooded off up towards the Environment Agency building. Best place to put a building in a flood zone. Right, so we're now sat in the Foss Basin. This gets wet. You can see over on the far side behind us, you've got the Foss Barrier. That's the Foss Barrier pumping station. Just further around the corner, you've actually got Foss Barrier itself. The barrier being the drop gate, the pumping station being the pumping station. Both independent, but they work together as a combined structure. The gate has a dead man's drop, so if such a thing as the power does go for York, you can just drop that gate. Let it drop in, let it do its thing. Pumping station obviously requires the electricity to function. So once the scheme was identified and there was an emergency package put together to fix the asset, what immediately happened was the area where we stood initially with all the shuttering, a set of 1 ton Tetra blocks was provided, creating a new pump station, temporary asset, immediately adjacent to the main pumping station itself, allowing the pump station upgrades to occur. The pump station itself initially had around a 6 cubic metres per second discharge rate, so it could shift a decent amount of water, but not what you needed for that event. Given that the asset was built in around the 60s and the pumps hadn't been updated since around the 80s when they were reaching their design life, what was decided was that actually they were going to change them out. So as part of the upgrade package, revised and looked at what the civil structure could take, looking at the pump wells, looking at the electricity supply, looking at the structure of the actual pumping station, identified that actually we could increase the pump capacity without having to do any civils modifications. I think the high level figures were something like 25 QMEX, so an increase of about 5 times what could previously be done. So that was identified and built into that current pump station. Now, what you can't see is where the temporary pumps were placed. They were put immediately to the side of the pump station, just to the right hand side as you're all looking. The pumps had a similar capacity, they had around 20 QMEX. The site, the temporary site, was actually quite impressive. Had a large diesel tank to provide backup for the generators that could drive the pumps, but it also had all of the electrical components required to drive the pump impellers as well. Now, to drive some of these pump impellers takes a massive amount of power. It needed an upgrade to the pump station in terms of electricity supply, and they ended up putting, I think, 2 armoured 10 kV wires in, which essentially means that pump station could power most of York itself. The pump station, as part of the new EelReg guidance, had to be fish friendly. Now, we've got some really big pumps in there. They are going to mince anything that gets near it. So what the process is for the pumps triggering is they actually start off at a really slow speed, essentially scaring the fish away. Slightly more technical, but that's what it does. The fish and the fauna within the basin essentially evacuate the front of the pump area, and as the pumps power up, start getting more and more flow going through them, they're able to send more. Now, not sure how much experience everyone's got of pumps, but essentially the way the pumps work, lift it up and then drop it back down. So you allow the water to be raised up out of the basin and then discharged out into the River Ouse. So what we'll do, we'll take a bit of a further walk around, if everyone's got no questions, and then we'll have a look and you can see how the barrier operates in relation to the pump station.